Now we are going to discuss the overcurrent relays. So as the name goes, the relay will operate in case of an overcurrent. Okay. So now what will be the torque equation for the overcurrent relay? This is going to be, if you remember from the universal torque equation, you had one term relating to the current and the other term which is relating to the spring. Okay. So the current is going to act as the operating torque. Okay. So you can take the magnitude of current here because it is anyway square, and the spring torque, this we will take as a restraining torque, so we will take minus K4. Okay. So this is the torque equation for an overcurrent relay. Now what will happen here, you will better understand what is the restraining torque, right? The relay will operate when there is a torque. Okay. That means when torque is greater than 0. Okay. Relay operates when torque is greater than 0. That means K1 I square minus K4 should be greater than 0. So from here what will you get the magnitude of current? This should be greater than root over K4 by K1. So this means what? This means that if the current is equal to the magnitude of current, if it is equal to root over K4 by K1, beyond this value the relay is operating. So this should be what? The pickup value. Okay. So in this way the restraining torque helps you set a pickup value. Only if the current exceeds this value the relay will operate. Next is types of overcurrent relay. So depending on the operating time of the relay, they are divided into various types. Okay. The first type is the instantaneous overcurrent relay. So here the relay is going to operate immediately. There will be some operating time, but no additional intentional time delay is provided. Okay. So no intentional time delay is provided. So we discussed the characteristics of relay, right? The speed, it should not be too fast so that it keeps tripping over every transient fault, right? So that's why this is one type of overcurrent relay. There is no intentional time delay provided. Okay. So operating time will be approximately 0.1 second. Next is definite time overcurrent relay. So here what is going to happen? There is going to be an intentional time delay. So intentional time delay is present. The next one is inverse time current relay. So here what is going to happen? The operating time is going to depend on the magnitude of the fault current. Okay. So operating time depends on severity of the fault. So if the fault is more severe, that means the fault current is very large, then the operating time will be lesser. So there is an inverse relationship between the operating time and the fault current. So again, depending on this inverse relationship, the inverse time current delay is divided into further types. Okay, and one of the most notable and the often used relay is the IDMT relay, which is the inverse definite minimum time overcurrent relay. So what happens in this kind of relay is there will be an inverse relationship when the fault current is nearer to the pickup value. Okay, but as the fault current increases, time of operation will remain almost the same. Okay, so inverse relationship when fault current is nearer to the pickup value, but then again as fault current increases, operating time remains almost same. Okay, and again Next further we have very inverse relay. So here the inverse relationship, it is going to hold for a greater magnitude of fault current. Okay, and further if you want the inverse relationship to hold for a still further magnitude of fault current, then there is going to be extremely inverse relay. Now one important quantity here is the plug setting multiplier. So this is abbreviated as PSM. So this lets you change the pickup current values, pickup current level. Okay. So it is given by PSM is equal to fault current divided by relay current setting into the current transformer ratio. Okay. So the fault current here is the current that is flowing through the actual transmission line, right? So it is the primary coil of the CT, that fault current, okay, divided by the relay current setting into CT ratio. Now the relay current setting is the value of current at which the relay will operate. Basically the relay is a coil, right? Now there will be some current flowing through it. When a certain value of current is exceeded, then the relay will operate. Okay. Now what happens? There will be tappings on these coils. Okay. And depending on the tappings, the relay will operate at different values of current. Okay. So at which value, at which setting we put, depending on that we have a relay current setting. Okay. So that value is this. We will do a problem on this, then it will become more clear to you. Next is the time setting multiplier. This is abbreviated as TSM. So this is given by the actual operating time divided by time for the corresponding PSM obtained from the time current characteristics. For any relay, there is going to be a operating time versus the PSM characteristics. Okay. So from there, for the particular value of PSM, what is the time that you have to take here in the denominator. So that is going to give you the TSM. Determine the time of operation of a relay of rating 5 amperes IDMT and having a relay setting of 125% TMS is equal to 0.6. It is connected to a supply circuit through a CT 400 by 5 ratio. The fault current is 4000 amperes. So here you have PSM versus operating time characteristics. So now first we will do, we will write down the given information. So here it is given that the relay rating is 5 amperes. That means it will work, the relay will work when the 5 amperes flows through it. Okay. So the pickup value, it is given as 5 amperes. Next, having a relay setting of 125% is given, right? So relay setting is equal to 1.25. Okay. And TMS is given, time multiplier setting. This is 0.6. And next what is given? CT ratio is given. This is 400 by 5. And the fault current is 4000 amperes. Okay. Now the question is to find out the operation time, right? So how will you find the time of operation? We know that the time setting multiplier or the time multiplier setting, this is given by operation time divided by time value for corresponding PSM, right? So if you want the operation time, you need the TSM and the this time value. Okay. Now TMS we know anyways, so we need to find this. Okay. Now for corresponding PSM, that means we have to first find the plug setting multiplier, and for that plug setting multiplier we have to find what is the corresponding operating time. Okay. So the plug setting multiplier, this is given by the fault current divided by relay current setting into the CT ratio. Okay. So fault current, anyways it is known, 4000. Now relay current setting, here the relay setting is given as 1.25. Okay. Now the pickup value is 5 amperes. Relay setting is 1.25. This means that the relay current will be 1.25 times the pickup value. That will be the current at which the relay will operate. That is the relay current. Okay. So here we can write into 1.25 into 5. Okay. Into CT ratio is 400 by 5. Okay. So this, if you calculate, you are going to get the PSM value as 8. So for this corresponding PSM value, is it given? Yes, here you have PSM 8, and for that operating time is 3.2. Okay. So that we have to substitute in this formula. So you can write TSM is equal to operating time divided by time corresponding to PSM is equal to 8. Okay. So TSM, anyways it is given as what? 0.6. This is equal to operating time, required operating time divided by 3.2. Okay. So from here you are going to get the operating time is equal to 3.2 into 0.6. You are going to get 1.92 second.